All right, I think we're back. So I hope you're well. Let's see. We left off talking about people boxes, and I missed some of the stuff that I tried to tell you. So I'm going to see if we can get it back up here. So a few things. I'm just going to pull this up. The big difference here for Part B, I mentioned that you could, you didn't hear this, but if you had heard it, you could treat Part B and C as z-tests and treat either the individuals. So let's look at the document here that you should have. You could treat the individuals, in this case citizens, as your unit of analysis, your element. In Part C, you could consider properties your element, in which case you're asking each property or each citizen a yes or no question. And if that's the case, let's make sure we're still live here. It looks like we're still live. If that's the case, you need a z-test of two proportions. Alternatively, you can treat cities as your unit of analysis, your element, in which case you're asking each city what proportion of your citizens work from home. And cities are going to answer that with a number, which turns this into a t-test. Now, the interpretations are a little bit different. If you run a t-test of this, then you're treating each city as an independent element. So cities are weighted evenly. If you treat citizens as your elements, then your larger cities are being counted. Your population weighting your cities. Similarly, in Part C here, you're weighting your cities by the number of households, as opposed to the cities being evenly weighted. Okay, but so you can treat these middle two as z-tests or t-tests. If you do treat them as z-tests, you need p bar 1 and p bar 2. If you treat them as t-tests, then the formulas can be exactly the same. But now you're considering a column z variable that I created here. Created a few new variables here. I'll hover over them so you can see. Percent retired we created before. Working at home, that's going to be U divided by L. That's our working at home divided by population. Percent owner occupied, that's W divided by X. That's our owner occupied divided by our total housing units. And then household size, that I had written that up here. Household size is a little bit different. You take your total population and divide it by the number of households. So it's people per household. And then from there on, it's more or less the same as you go. All right, so that's everything that I have in terms of people boxes. Should give you enough to dig in and take a first crack at it. So now let's switch gears. Let's look over here at pet health. Pet health for Part 2, we're looking at device type. So let's take a look. Let's see, pet health here. So I have the raw data. Let me clean it quickly. Again, I'm right-clicking and pressing D to delete these columns. Similarly, I'll delete this one and delete this one. And I don't actually need any of this stuff, so let's get rid of that. To take care of the rest, we want to select all. We can sort it by, it doesn't matter, let's sort it by, well, my data has headers now. Sort it by date, should be fine. Still got one column here. I think that's junk. And now we've got all our data. At the bottom, we've got all these dashes now that we sorted it. So let's get rid of these dashes, 55, 42, and below. Okay, so my data is all cleaned. The first part says, has device type changed? The first year's data is from 2007. Test to see if the proportion of visits in 2007 differs from the proportion of visits in 2012. So again, we didn't talk about this in the other case. You could use this for the other one, but it's not imperative. But I'm gonna draw it up here in any case. If we're testing difference of two proportions, it's a z-curve, so it's a normal distribution, z-statistic. We're gonna get p bar 1 minus p bar 2, over the square root of p bar, and this was in your notes, so if you want to take a look at the notes from, I want to say, let's do samples, so 10 maybe, p bar times 1 minus p bar times 1 over n1 plus 1 over n2, I believe that's correct. And again, sorry I don't have a touch screen, but hopefully that's totally legible. Now, in order to calculate that, we need to be able to look at 2007 and 2012. To do that, I'm actually going to create a year column here. There's a real handy formula called equals year. And you see it says serial number there, right there. If you feed it any date in there, dates are stored as serial numbers in Excel. And it'll just pull the year out. So that's 2007. And then if I copy and paste that down, it pulls the year from everything. And the reason I'm doing that is that I'm going to want to look at device type. So device type is right here with browser classification, desktop or mobile. Those are the device types. And so I've got desktop, desktop and mobile. And I'm going to use a Countifs formula. There are other ways to do this. But the nice thing about Countifs is it lets us count criteria range. Lets us count every occurrence within a given range. And I'm using absolute references here, so it stays there. And I want it to count anywhere in here where the number is 2007. And I also want it to count anywhere in here. And again, I'm converting to absolute references there, where it's desktop. And you'll see that my absolute references for my criteria are a little bit different. This is because I want to set it up so that I should be able to copy and paste this, and it'll move. So you can see that the thing that differed here is it was at desktop 2007, and now it's at mobile 2007. And I also am going to need data on 2012. And you can see that the absolute and relative references are set up such that the device type stays within the P column. That's why the little $ right there stays there. And then the year stays within the first row, because that's what I want. All right, now the question, going back to the question, they want to know if the proportion of visits in 2007 by a particular type differed from 2012. So a quick way to do that is to create a total variable here, and we can just sum these two up. And then let's do, it doesn't matter what you pick, but let's say that we want proportion of desktop. To calculate that, then we would just take this number here, divided by this number here, and the same here. And actually, to finish this, I'm going to need to create a total, which is the sum of these two values, because I need to come up with P-bar, which is across the two pooled, right? So that total is a pooled proportion. And so 730 out of 899 is the pooled. So what I now have here, and I don't have them labeled well, so let's fix that, is that this number right here is P-bar 1, this number right here is P-bar 2, and this number here is P-bar. Similarly, the number above this is N1, and the number above this is N2. So this already has all the numbers that I need to calculate my z-statistic. So for step 1, I want to state my hypotheses. This is part 2a. My null is going to be, let's see, is it that there's no difference? If it differs, yep, so P1 minus P2 equals 0. My alternative is going to be P1 minus P2 does not equal 0. Step 2 is to choose a level of significance. Step 2, alpha equals 0.05 is the most straightforward. Step 3 is to choose a test statistic. We already talked about it. It's this one here. I'm not going to copy it over, but that's how we would find that. And then in order to calculate that value, we would need, just check and see if I'm still on here. Still live, 9 minutes in, still live. Okay, in here what we need to calculate this, we already have P-bar 1, P-bar 2, so we can calculate a z-numerator. That's going to be the difference between P-bar 1 minus P-bar 2. So that's our z-numerator. And then for our denominator, we're going to need P-bar, which we already have. I'm just going to pull it down here to make it a little more convenient. Then we need 1 minus P-bar, which is 1 minus this. And then we need 1 over N1, which is 1 divided by 255. And then we need 1 over N2, which is 1 divided by 644. Then we need the sum of those. So we can add this to this. And then we're going to need the variance, which is the product of all three of those. So we've got p bar times 1 minus p bar times the sum of the inverses. That's our variance. And then our z denominator, the standard error, is the square root of that variance. So that is what we have under the fraction bar. This allows us to get our z, which is the numerator divided by the denominator. And so we've got a z-score of 1.50. Now looking at that, I can tell we're going to fail to reject probably. But how do we calculate? This is step 4, by the way. 4 is all this stuff, because we already chose the z-statistic. Step 5 is to calculate the p-value. Now this is a two-tailed test. Norm dot, so let's, we got a z-curve, so we can do z dot, no, it's going to be norm dot s dot dist, isn't it? Okay, let's skip the p-value for now, because, well, let's talk about why. We've got norm dot s dot dist. It's a standard normal distribution. We feed it a z-curve, a z-distribution, sorry, a z-statistic, and tell it that we would like, the one there means we want the area under the curve, not the height of the curve. If we do that, that gives us an area, and this is always the left tail, the cumulative distribution. Now, because it's a two-tailed test, we want to find the area in the nearest tail, which is the right tail in this case, because z is positive. Now, if you know you have a two-tailed test, one good thing to do is actually you can always you can make sure that you're always looking at, if you turn this into absolute value, this is always giving you a larger left tail, because regardless, you're taking advantage of symmetry, and you're taking advantage of the symmetry, the absolute value, to always give yourself a left tail, even if you have a negative z-statistic. So if you know you have a two-tailed test, one good way to do it is to take the normal distribution of an absolute value. That way it doesn't matter which tail you're in. If you do that, then you can always get the right tail by doing 1 minus the normal distribution of the absolute value. And then your two-tail is going to be double that. So if you do essentially 2 times 1 minus norm dot s dot dist of the absolute value of your z-curve, comma 1, then that will always give you the correct two-tailed p-value, right? Because absolute value forces you to be in the right tail. 1 minus that always gives you the area in that right tail, and then 2 times that will give you the z-curve. Now I can do the same thing here I did with the other one, which I can use if this is greater than our alpha, and I'm doing it exactly backwards this time, fail to reject compared to the way I did before. Alternative, or otherwise we're going to reject the null. And here we can see that 13 is greater than 5, so we failed to reject. So that's how you do part 2a. So there's a couple things going on here, the countifs. Nothing super tricky once you know what you're doing, but if you don't know what you're doing, it's a little tricky. Alright, 2b is asking us to do a z-test. It says test to see if the average site length is shorter for mobile users than for desktop users. I don't actually know like a great way to do this. So now you can use average if to get the value of the average, but stdev.s is not going to be great to do it that way. So what I'm going to do now is I'm going to sort my data by client browser. Is that the browser classification? Is that it? Or is that? Yeah, desktop versus mobile. Because what I need to do in this case for 2b is I need to come up with I need a cut point. We've got 2 samples. So we've got desktop, and that's going to have x bar 1, x bar 2, I'm sorry, S1 and N1. And then we're going to have x bar 2, S2, and N2, where these ones relate to mobile users. And so for this, we'll take equals average, and this is for the site visit length. That's right here. And I want to get these for all the desktop users, so I'm holding shift and just pressing page down for a while. lot of them. Oh, surpassed it. Alright, so J2 to J4562, those are all desktop users. So J2 to J4562 is what I need. So I can do the same thing for here, J2, J4562. Let's make sure those are the same, yep. And then this last one for N, we're going to use equals count, J2, J4562. And then, same three formulas, but now we want J4563 to 5541, all the way to the bottom. Just the rest of these. So this right here starts at 4563 and then goes to 5541. And actually this is the range, so I can just copy that and then place that same range inside these. It's technically part of step 4, but while I'm thinking about the data, I might as well take care of that. Alright, so now again, step 1, it's asking us, is average site visit length shorter? So mu1 minus mu2, if mu1 is desktop, then it wants to know if it's shorter for mobile users. So if it's shorter, that means mu2 would be smaller. So I'm going to assume that mu2 is larger to see if I can prove, that's what they want us to do here, mu1 minus mu2 is greater than 0. That would be the case if mu2 was smaller than mu1, right? Because then you'd get a positive number. Big minus small is positive. Okay, same as before. Actually, I can just pull this over here. But now instead of a z statistic, we're going to be using a t statistic. Which we looked at earlier if you look at the other video. It's this one right here. Right, so we've already got our x bar 1, s1, and n1. I'm going to want s1 squared over n1. That's going to be handy. And so that's going to be this divided by, this squared divided by this. And I didn't set this up quite as conveniently. Squared divided by n2. What's this? Squared divided by this. That's fine. No biggie. And then our variance is actually the sum of those. And then that gives us our t denominator, which is the square root of this value. T numerator is going to be x bar 1 minus x bar 2 minus d0, which is this number here. And then our t statistic is going to be 2918 divided by 2497, 1.17. That's steps 3 and 4. Step 5 is to calculate the p-value. To do that, we need our degrees of freedom. I did this before in the other video. We'll do it again real quick here. We won't be able to find it right away. So first we need our z numerator. We already calculated our variance. It turns out our variance squared is a numerator, and you can see back in the land of the scientific notation. Then we need z denom. Actually, let's do 1 over n1 minus 1. It's 1 divided by, you can break this up as much as you want. This value minus 1, use parentheses there to be real careful. 1 divided by n2 minus 1. You can see I didn't use it here. Let's throw it back in, just for notation. Oh, there we are. Equals 1 divided by n2 minus 1. And now my z denom left, or not z denom, degrees of freedom denom left is going to be this times s1 squared over n1 squared. And then df denom right should just be able to copy and paste that, because you can see that it just slid down 1. Yep, there we go. Our df denominator then is going to be the sum of these two. And then our degrees of freedom is going to be, actually I already have a spot for it up here, so let's plop it where I saved. df numerator, which I called z numerator, let's fix that. df numerator equals equals this divided by, pardon me, a little bit of a cough, 1,627, which, you know, you see these two values, it's somewhere reasonably related to those two, same order of magnitude. Alright, since this was a right-tailed test, our p-value is going to be the right-tailed p-value. So we can do t.dis.rt. We've got our x there as our t-statistic, and then degrees of freedom. And then you can see there is our p-value. You can use the same if. If this is less than 0.05, we would reject. Otherwise, we fail to reject. The nice thing about doing if then is that if it turns out we screwed something up, the answer actually, the t-statistic turns out to be 4, it will switch our conclusion. And that's kind of nice. Okay, so that's how you do part 2b. Part 3 here is exactly the same as 2b or part 2c here, except instead of site visit length time, we're using load time. Part 4, okay, in order to do that, that's a lot like part D here. That's a lot like part B, part A, except our proportion is not going to be desktop versus mobile. It's going to be common household pets. In order to do that, actually, we probably need to create a new variable. So let's do common pet, let's say. And this is a really, a nested if is probably the fastest way to do that. So if we're going to look at the pet, if the pet equals dog, comma, 1, comma, if the pet, that's I2, equals cat, comma, 1, comma, if the pet, not pet, I2 equals, what does it say, bird, comma, 1, comma, and if the pet equals fish, comma, 1, comma, 0, close off our parentheses. And you can see all that does is it checks that cell right there. It says, is it equal to dog? If yes, it's 1, but it's not. So check here. If it's equal to cat, if it's yes, it's 1, which is not. So is it equal to bird? If yes, it's 1, no. If it's equal to fish, if yes, it's 1, and it is. So that should be a 1. And the next one's dog, should be a 1. Fish, cat, dog, chicken should be a 0. And so on and so forth. And so it should check each of these values here. Is this, what's it equal to here? And you can see other is a 0. There's a lot of common household pets. People really visit the website to check on their pets. But you can see horse is not a common household pet, so that's showing up as 0. And that's what those nested ifs are for. Getting fast at that really does help. So once we enter it once, you can press enter. Left, control down, right, control shift up, control D. Fills that whole thing down, 5,540 at once. And now, similar to the way we did here, but a little bit different. And so we're on part 2D now, let's say. We would want to know, you could use, let's see, mobile and desktop, same as before. So, but now, so if we just copy this stuff, let's see if that will be helpful to us. We're not looking at N anymore. We're now looking at column O. And we're not looking at column Q. We're looking at column AE. And we want this to be 0, maybe. Oops. And we want this to be 1. And so these, just to, let's see if we can slide this down a little bit. This is our common pet. If it's 0, it's 0, or if it's 0, it's not a common pet. If it's 1, it is a common pet. And this just builds out what we did before. Now, once you have these, you conduct this test exactly the same way as we did 2A. But all I did was kind of hijacked the material we were looking at before, which was what year they're visiting in. And now I'm checking to see, are they visiting, interested in a household pet. The last one here, are mobile users younger than desktop users? That right there is asking about their age, which we have, and then it's just a t-test like parts B and C. So that should give you the tools that you need to calculate all of do all the work for part 2 here. I'm confident that once you have that, that should give you the information you need to dig in. Obviously, feel free to pause, rewind, ask any questions you want. But hopefully that gives you enough to move through. And I wish you luck. Good luck. You're going to learn a lot of stuff. And thank you for your time and for your patience.